Good afternoon, everyone. We're just going to leave it a few seconds for people who are still making their way over from the waiting room into the meeting. Okay, so welcome to the TAPAS seminar series. TAPAS stands for Tackling Air Pollution at School. It's one of 6 networks funded by the NERC SPF Clean Air project, and this is our 3rd Lunchtime seminar series, bringing together speakers across areas of expertise that are linked to indoor air pollution, outdoor air pollution, and health. So my name is Mark Stetler. I'm a senior lecturer at Imperial College London and one of the co-Is of TAPAS, and I've got the pleasure of chairing this seminar today. Before I introduce our speaker, Chris Griffiths, I'm just going to go through a bit of housekeeping. So the session is recorded, so please keep yourselves on mute throughout the seminar. Feel free to post questions in the chat and we'll go through these at the end of the presentation. We'll try and get through all of the questions, and we'll draw the session to a close within the hour, so by 2 p.m. So yeah, I'm delighted to introduce Professor Chris Griffiths. He's Professor of Primary Care at the Wolfson Institute of Population Health at Queen Mary University of London. He's a co-director of the Asthma UK Centre for Applied Research and principal investigator at the MRC and Asthma UK Centre in Allergic Mechanisms of Asthma. He leads the PIL study, which stands for Children's Health in London and Luton, and which is an NIHR-funded cohort study evaluating the impact of London's Ultra Low Emission Zone on children's health and development. And that's what he's going to be talking to us today about. So Chris, welcome, and the floor is yours.
Great, thanks. It's a pleasure to be here. Thanks for inviting me. I'm speaking from a conference, so if I get interrupted, please forgive me. So I'd like to present the status of the CHILD study on behalf of all the collaborators. So let me first take you back in time to London's first low emission zone, and that was implemented from 2008 to 2012. And without much money, I have to say, we evaluated the impacts of the first low emission zone on health, and this was the Exhale study, the precursor really to CHILD. And you can see on the left-hand side of your screen 6 panels here, and they're labelled 2008, 2009 through to 2013. And on the side, you've got this scale here of nitrogen dioxide levels. Anything that's yellow downwards, orange to red, is above the European limit value of 40 micrograms per metre. And so just looking at that part of the slide to start with, you can see that as we move from 2008, 2009, in 2009, 99% of the children who are represented by these tiny dots where they live, this is an area of East London. You can just see the oxbow of EastEnders at the bottom there. So this is Newham and Tower Hamlets, and 99% of the kids we recruited to this study from primary schools lived in areas which were above the European limit value for nitrogen dioxide. And as we go through 2010, 2011, 2012, 2013, at the end of the study, it had reduced to 34%. So there was some indication that the implementation of London's first low emission zone did have some impact on air quality. And if you look at this panel in the middle, you can see the top purple line just slightly glancing downwards is inner London roadside nitrogen dioxide, and these others are inner London background and so forth. That's the key at the bottom there. And here's the EU limit value. And you really have to have the eye of faith to say that it's going down, but in fact, it did go down over time. The panels on the right, I can't see them now because they're blocked out by by some of the panels of participants. But these were estimates of changes in nitrogen dioxide over the course of the LES. And the summary statistic at the bottom of these two, as background and roadside, show that there was about a 1 microgram per meter cube reduction per year in nitrogen dioxide levels. So a bit weak, really. And we didn't find much in the way of health benefits at all, or to put it bluntly, we didn't find any health benefits. But what we did find, moving on to the next slide, was that there was a relationship between nitrogen dioxide annual exposures and the lung capacity of the children. So there are two panels here. The one on the left describes FEV1, so that's the amount of air that's blown out during spirometry by our children in this study in 1 second. And on the right, the panel is forced vital capacity. I should say that we worked with about 25 schools, and each year we recruited a new sample of children from year 4. And so it wasn't a cohort study, it was a sequential cross-sectional study. And we ended up with about 2,500 children in the study, and we carried out spirometry to assess their lung function and lung capacity. And we were able to relate lung capacity to annual exposures. Those are described with this grayed out bar in both of the two graphs, and recent exposures. So if the day of the assessment was the 30th, then we could look at exposures in the week before, 24 hours before, and even on the morning of the exposure. But there was no relationship with those acute recent exposure levels, but there was a relationship with annual exposures. And we found that for every extra microgram per meter cubed of nitrogen dioxide annual exposure for these children, there was a deficit in lung capacity. And if you look at the red line, horizontal line that shoots across to the y-axis, it hits the y-axis at somewhere between 2 mils and 2.5 mils. So for every microgram per meter cubed, there was over a 2 mil deficit in lung capacity. And remember, these kids were living in areas really high nitrogen dioxide, over sort of 40, 50, sometimes even higher, the roadside values up to 70 or 80 micrograms per meter cubed. So if you scale that up, you find that you can reckon that the lung deficit capacity in these children was something approaching 100 mils. Hence these two eggs, which together account for about 100 mils of volume. And so this is a significant percentage deficit in lung capacity that relates to their air pollution exposure, particularly specifically the nitrogen dioxide. And these are findings that chime with other studies from around the world, in particular the California Children's Health Study, but there was also analyses from the east side of the of the States and Europe. So our findings were perhaps reproducing others, but they were in the very diesel-dominated environment of London, which was quite different to the if you like, describe it as a petrol gasoline-dominated environment in California. And so they are novel in that respect. And we know that diesel is a really hot topic in terms of air pollution, particularly in the UK. Why does it matter? Well, if you're a child and you reach through adolescence and adulthood with smaller lung capacity, then you're at risk of longer term lung problems, whether that's new onset or asthma or earlier onset of COPD, because the lower the level that you start, your peak of lung growth, the lower that level is, the sooner you'll reach levels where you can become symptomatic if you're predisposed to COPD, for example, in other ways. So it matters that children's lung growth and development is being stunted by air pollution. So this is a sort of rapid summary of what I've called what we know and what we don't know. So air pollution stunts growth in children and adolescents. Work by the in the Children's Health Study subsequently showed that you can get some partial growth recovery of lung capacity if the air quality improves. So in adolescents, there's evidence that you can recover some growth. And the data on whether low emissions actually improve or don't improve air quality is pretty mixed. There's a review, Cochrane review out, I think a couple of years ago, saying that some did and some didn't. Just give me a second.
We can attempt to keep it.
Sorry, just asking some people to speak quietly next to me. So low emission zones may or may not improve air quality depending on their design and geography and so forth. But an important question really for us is, can low emission zones improve quality, and can they improve children's health and development? And that doesn't just apply to lung development. You may be familiar with data that shows that air pollution in children can delay cognitive development. So we're saying that this is delaying lung and brain development in children, and those are pretty two important organs in a developing child. So our findings influenced the configuration of the ultra low emission zone for certainly for a long time. On the TfL Transport for London website, it specifically said, why do we need an ultra low emission zone? And it said because air pollution is damaging the growth of children's lungs. So as you know, probably the ultra low emission zone was implemented from April 2019, and it was implemented initially right in the epicenter of London. And a few weeks ago, there was an extension of the restrictions out to the area bounded by north and south circular, and in the meantime there was a tightening of the original low emission zone across the whole of London. So there has been a sort of phased tightening over time of air quality restrictions in London. So the creation of the ultra low emission zone gave us an opportunity for a natural experiment. And so we applied to NIHR Public Health Research for funds to carry this out. And the hypothesis is really, as I stated, that improvements in air quality derived from the ULEZ would improve health and development of children living in heavily trafficked areas. So we set up a parallel prospective cohort study, which is different to pretty much every air pollution study that I've come across. A lot of studies, as you'll know, use interrupted time series analyses where you define an inflection point and you look at what happened before and what happened after that inflection point on a series of measurements. The benefit of a parallel cohort study is that you identify, in this context, a comparison geographical area that's similar in as many characteristics as possible. So it's air pollution exposures, the demography of the population, and so forth. And the benefit of that is that it, at least in theory, allows you to better account for secular trends that are going on. So in this context, there are national policies which are improving air quality over time. There are changes in people's behaviour over time, and it's important to try and tease out the relative contribution of national policies from a local initiative such as the ULEZ. And if that cohort study can include a range of assessments, so direct physiological assessments of individuals, can look at health records, can even include DNA sampling to incorporate genetic influences, then you've got a much stronger study. So that's what we set out, what we proposed. And on the right here, it's just expressed in PICO format. The population of this study are children aged 6 to 9 from primary schools, years 2, 3 and 4, living within the central London ULEZ zone. The intervention is the ULEZ. The comparison is children in Luton. I'll come back to that in a second. And the outcomes for our study are lung growth development, so it's post-bronchodilator, FEV1, and secondary outcomes are air quality, a range of other spirometric values, and respiratory symptoms and coughs and so forth. And we took the opportunity at the start to get in touch with Cambridge CEDAR group in the epidemiology unit and say, well, you're interested in physical activity. Do you want to link up and let's try and measure whether physical activity and obesity change in children as they hopefully live in a progressively more conducive environment for outdoor exercise and so forth. And we also, after a year, managed to start measuring cognitive development. In the children, we linked up with colleagues in Bradford and Leeds, and we got some funding, proper funding, rather than just doing it out of our own coffers from Bart's charity. And we've also been taking DNA samples to look at epigenetic associations with air pollution exposures. So that's the format of CHEL described as in PICO format. Why Luton? You might think that Luton may not at first sight be a good comparison site to London, but on reflection you might think, well, it has got an airport and that sucks in a load of traffic into the city. It has the M1 and the A505 running through it, and it's got its own automotive industry, Vauxhall, there. So it's surprisingly, it turns out to be quite a good comparator. And the other feature is that the demography of the population is quite multi-ethnic, not dissimilar to London. So there's some good justification for choosing Luton as a comparator site, not least of which it's not that far from London, so the study team can shuttle back and forth to do the assessments. This is a schematic diagram of the CHIL study, and this blue arrow in the center here describes progressive implementation of the ULEZ. We started the study in 2018 and we had a year to establish the cohort, and we have annual assessments of the children in school visits. So the ULEZ was implemented after 2019, at the start of 2019, and I've got another green line here showing the recent expansion of the ULEZ, and the vertical red line is effectively where we are now, which is entering year 4. But as you'll see, those things have changed in recent months because of certain events related to coronavirus. So that's the overall structure of the study. Annual sequential school visits to assess the primary outcome measure, which in this case is spirometric estimation of FEV1. These just show the years where we've been measuring cognitive development. So that started in year 2 of the study, and we'll be moving into the 3rd year of cognitive development assessments shortly. This slide shows the location of schools in London and Luton. You can make out the River Thames here, and this sort of inner circle of roads that defines the ULEZ. We included schools that had children living in the catchment area, whose catchment areas crossed over into the ULEZ area. And we ended up with 44 schools in London and 41 in Luton. And this slide really just shows the trajectory of recruitment. It was a big struggle to recruit the cohort, which had to be done prior to the implementation of the ultra low emission zone. So we were able to take baseline measurements before the introduction of the ULEZ, recognizing that there's some behavior change. People's purchasing and driving habits happens before the actual date. But essentially, we established the cohort prior to the starting gun for the ULEZ. Our data sources, as I said, are annual school visits, height and weight, spirometry, physical activity measurements, a caregiver questionnaire, respiratory symptoms, Isaac scale, quality of life, the TU9D, and non-NHS costs. And we'll be looking at health records at the end of the study, and the air quality monitoring is as you can see there. Okay, and overall, the participants really divided roughly into a third white, a third South Asian of different types, and then a third of a range of other ethnic groups. And there's a slight difference between London and Luton, in that London has rather more African and Afro-Caribbean children. Luton has relatively few. Luton has a slightly different profile of South Asian participants. For example, London's got just slightly more Bangladeshi children. But this is a group of children who are multi-ethnic and living in highly trafficked areas, largely from disadvantaged backgrounds. So this is the baseline spirometry data, and the whole idea of a parallel cohort is that hopefully you've got well-matched participants at the start. And if we look at, first of all, at the lower panel, in London, the mean FEV1 of children was 1.49 litres, and in Luton it was 1.50 litres. That equated to a predicted value of 99% in London, 101 in Luton. And if we look at forced vital capacity, again, the two measures are pretty much identical, 1.75 litres versus 1.77 litres. So that was really pleasing that we started off with similar measures in the primary outcome. Good quality spirometry is obviously critical. It's quite difficult in year 2 children because they're quite tiny, but we assumed that we might get 70% success, but we hit 83%, which was good. One of the worries about a cohort study is attrition over time. We banked on at least, I think, 10% attrition. I think there's 20% attrition. I can't see it on the slide, but in the first year we only had 8%. Sorry, into the second year we only had 8% attrition. So at least initially we were retaining kids quite successfully in the cohort. And this is some baseline physical activity data. In the top right, you can see the actigraph monitors that the children wear for a week, and then we try to get them back from them, which is quite difficult. Sometimes they send us very sweet notes saying how they've lost them, and they're very worried about it. So if you look on the left, the baseline profile, this is MVPA is moderate to vigorous physical activity. So you can see that London children seem to be engaged in slightly higher time spent in moderate vigorous physical activity compared with Luton. And you can see in just below in panel 2, the method of commuting to school may be partly explained by this. In Luton, the schools have quite big catchment areas and a large number of kids per number of classes per year, sometimes 5 classes for a school year. And so kids have to often travel that much further. And so kids in London are engaged in more active travel than those in Luton, probably because they're walking or cycling to school. And if you look on the right of this slide, these are some charts from the actigraphs, and basically the blue peaks are usually 4 in a day. Kids getting to school, playtime, lunchtime, and then coming back from school. So there's a pattern in those actigraphs which chimes with the sorts of activities that the kids are engaged in. I'm going to talk a bit now about the school outreach because I know you'll be interested in this within the TAPAS network. So we applied NIHR. Basically, they said your grant request is much too much money. Please cut it back. And of course, ultimately, we were only able to get funding for 1 year of science outreach, but it's a really important component of the study. I'll come on to a bit more in a second, but this is launch day, and we launched it. The study simultaneously in London and Luton, with the mayors launching the program. This is Sadiq Khan getting involved in one of the outreach sessions. So the outreach sessions, they're interactive. We try to get the kids engaged in science. They delivered at the time of the annual health visit. We offer them to the whole school year, not just the participants or the class that the kids have come from. We think it's a big incentive to schools to stay part, and it's something of a glue to retain them in the study. And we've been reaching really up to about 9,000 students a year. And this is important because, as I said, this is a group of kids who are often from disadvantaged backgrounds. And so getting them engaged in STEM discussions is a really important thing to do. And absolutely, these outreach sessions are hugely well received. That's the feedback is fantastic from them. And we did get further funding, managed to get further funding from Bart's charity. And so each year we've done something slightly different in relation to, and that's linked to what we've been doing in the study. So in the first year we talked, the session was about respiratory health and lungs and air pollution. In the second year we were sampling saliva for DNA. And so the whole program was framed around genes and health. And the third year, because we started in earnest cognitive development, the sessions are around brain and nerve development. I'll just look at the bottom right panel, which is a sort of I can't remember what they call, word something or other, word cloud. That's right. So I mean, kids feedback. It's interesting, exciting, fun, fascinating, extraordinary, educational, and so just to emphasise that these are really well received. So we were going really nicely, and along came COVID, and the school shut down. And if you're running a study which is totally dependent on school visits for your health assessment and primary outcome data collection, then basically you're stuffed. And so we had a really frustrating year from the first lockdown in March 2020. As you may know, spirometry is an aerosol generating procedure, and as such, it was effectively banned. We couldn't justify doing spirometry in schools. Eventually, things moved forward. There were a lot more data about ventilation, monitoring CO2 levels and so forth. Initially, we were finally able to go back to schools and do spirometry outside in and the gazebos, which was frankly awful, cold and unpleasant, but at least it was a way of gathering some data. But you can see on this, basically this red bar is the data that we were unable to collect. We lost about 25%, couldn't visit 25% of schools at the end of the year to data collection, and we were only able to restart data collection to get a small number of schools in year 3. So this has been an extraordinarily difficult thing to deal with respect to the study. So if you think about it, there's quite a lot of ways in which COVID could affect a study like this. We had 3 lockdowns, as I'm sure you're all too familiar with those, but they altered traffic flows. The ULEZ was briefly suspended, and there were changes in air quality. As I said, we lost data collection, and that contributed to a massive loss of study power. We calculated that we only now had about 30% power for the study, which was originally powered at 90%. And other impacts on healthcare demand and mental health and work patterns and economic activity. And then a final difficulty is, although coronavirus may not make children very symptomatic, there's at least a theoretical possibility that it damages lung development in the long term. So it could impact directly on the study's primary outcome. So this slide really is don't look at all the boxes, but it's the first year, the second year, the third year of the study. But it's really just to emphasise that we missed a whole load of schools at the end of year 2, and we missed a huge number of schools in year 3, as I've already mentioned. And so we're also seeing in year 3 a much bigger attrition of kids leaving the study, about 18%, 17–18%. So what did we do? As I said, we eventually were able to do spirometry outdoors, lots of risk assessments, lots of bureaucracy. We went back to NIHR, and they very helpfully awarded us extra money for a 5th year of data collection. And these primary school kids, the ones in the older years, as we go through the study, they move into secondary school. And originally we were powered such that we didn't need to follow them into secondary school, but now the only way of achieving power is to add a 5th year and follow the kids into secondary school, and we really don't know whether we're going to be successful in doing that. And then finally, we are just about to start COVID-19 antibody testing in children with capillary fingerprint samples. So this slide just shows the extra 5th year added on to the study, those in red. So I'm just going to end really with slides addressing the really tricky question of how much has COVID altered air quality that the children participants are exposed to, because it may be really quite difficult to tease out the differential effect of the ULEZ and the COVID-related lockdowns. So this slide shows all the monitoring stations in the ULEZ area. The roadside ones are marked by cars, and the background ones are marked by little houses. This is data just very recently provided by my colleague Ian Mudway at Imperial in the environmental research group. And so he's gathered all the monitoring data from those sites. And I'd suggest you just look at the left-hand panel here. This is air quality nitrogen dioxide from 2017 to 2021 at roadside, and the nitrogen dioxide levels on the y-axis 50, 100 micrograms, 150. And you can this vertical line marks the toxicity charge, and this line marks the implementation of the ULEZ, the ULEZ suspension during COVID, and this last line is the expansion of the ULEZ, which happened a few weeks ago. And you can see that nitrogen dioxide varies a lot. But there's a slight downward trend, just as we saw in the discussion of the low emission zone study. And then with the ULEZ, there's a steeper decline, and you've seen there's some data showing that it's about a 30% reduction overall in nitrogen dioxide levels. But what isn't, or rather, what this shows is there doesn't seem to be a huge effect of ULEZ suspension on nitrogen dioxide levels. There's possibly some fall. It'd be a little bit clearer when we define this as means. But the significant fall in nitrogen dioxide has happened quite quickly after the ULEZ, and it's pretty horizontal thereafter. If we just compare that with Luton, the number of monitoring stations is much less in Luton, but you can see that nitrogen dioxide levels are pretty high. So you can see that if that's 100, then a lot of the measurements are around or about 100 micrograms per litre, not dissimilar from these levels before the ULEZ was introduced. You can see possibly a downward secular trend, probably resulting from national policies. And again, there doesn't seem to be a huge reduction in a discernible reduction even in nitrogen dioxide that occurred at the time of the ULEZ suspension and the lockdowns. This is the same data for PM 2.5, which is relatively less influenced by tailpipe emissions, and it's pretty flat. Maybe gone down a little bit after the ULEZ, and in Luton again pretty flat. So that's data that is a little bit reassuring to suggest that although coronavirus has had major societal impacts, it may not have had quite the large impacts on air quality that would corrupt or make our study more difficult. So really, that's where we are with the study. We've got a robust parallel prospective cohort. We've got great school engagement and child recruitment. We've got high quality spirometry. We've got a good balance across the two sites, but we've got major COVID-19 disruption, and we've had to try to mitigate this as the best we can, and really how successful we are in doing that remains to be seen. So finally, CHIL involves a huge load of institutions and people, and it's a huge collaborative effort. So this is on behalf and acknowledges everybody's help. Thanks.
Great, thank you, Chris. We have a question in the chat, so I'll go straight to that one. I think it relates to some material you presented earlier on in your talk. And the question is from Richard Daniels. Did you find a different magnitude of effect in London with diesel-dominated fumes, or in the USA with petrol gasoline-dominated fumes?
Is there a difference? It's I don't think it is that different. I'd have to look it up. This is Jim Gauderman's work, and that's published in the New England Journal. But my recollection, because Jim was talking about it recently, was that the magnitude was not that different.
Okay, Richard, if you have any follow-up, then please do put it into the chat, and anybody else who's got a question, please type it into the chat. We have another one here. Do you support the 4 times reduction in NO2 levels given by the new WHO guidelines?
Yes. Sorry, was that specifically nitrogen dioxide you were referring to?
Yeah, the question is specifically referring to nitrogen dioxide, but you might also want to comment on the other pollutants. Yes, I do. I mean, I think they've done a huge job of reviewing the literature, and even before they did, in their report a few weeks ago, it was pretty clear that there weren't obvious threshold values below which everyone was safe and could relax. And a lot of the data shows that health effects occur below the existing threshold levels. So absolutely, I do support those new values. And also for particulates as well. So it's disappointing that the government is not voting into law the new particulate thresholds. Chris, we just lost you there for a second, and you've gone on to mute. So I think you can unmute yourself.
Is that better?
Yeah, that's better.
Yeah. So basically, yes, I do support those recommended thresholds.
Thanks. So quite a few questions coming through. The next one from Jemima Hartshawn. What research could we look at that would help work out the next best step after ULEZ to reduce pollution?
Sorry, I missed the second part of it. What research could we do?
Could we do to look at the next step after ULEZ, so beyond ULEZ, to reduce pollution?
Yeah, I think that's a really interesting question. I mean, there's going to be a drive now towards decarbonisation and electric vehicles. So obviously, it's going to be. It may well be that particularly nitrogen dioxide levels fall quite significantly over the coming years. But then there's the question of particulate effects related to electric vehicles, zero emission vehicles. And so, you might say, well, why are you bothering to do this ULEZ stuff? Because it will be sorted out in a few years' time, and the problem will have gone away anyway. But I think that the next phase of research is trying to understand the health effects of zero emission vehicles, because there's a different profile of particulates which are thrown out or thrown up by those vehicles, and it's going to be really important to understand whether we need to be worried or whether we don't need to be worried. So that's important. I mean, the other work that needs to be done is, let's say this shows that the ULEZ is highly effective at improving air quality. Then there's a lot of and has a health benefit. Then there's a lot of work to disseminate that and make sure that the clean air zones in the UK and everywhere else are as effective as they should be. That's really an implementation issue, but the more data there is, the more secure the recommendations, and how easy it is to sidestep these inconvenient policies that interfere with our existence. So more data is good.
And on that point, so there's a question here from Sophie, which may have been sent to her anonymously. From what you've seen so far, do you think the ULEZ has had a positive health impact?
Well, that's really difficult to say. I think because it's made a difference to nitrogen dioxide levels, I think that, or at least those figures show that nitrogen dioxide levels have fallen. I think there's a reasonable chance we will show a health benefit. But remember, in this study, we have got a better way of accounting for secular trends. So really, this is quite we've set quite a difficult target here, because if we weren't bothered about secular trends, we could say, well, look, nitrogen dioxide's dropped fantastically. It's all down to the ULEZ, but it won't. What we see in London isn't all down to the ULEZ. It's a combination of national secular trends, policies, people's changes in behaviour. It's also related to other measures that have happened in London, like retrofitting buses and so forth. So if you were a purist and saying, well, has the ULEZ done it, then we might well not be able to show a difference, because we will be subtracting out the secular trends from national policies that we'll be able to define from the Luton comparison zone. So, in answer to your question, has it worked? I hope it works. Everybody likes a positive finding in their studies, and they're always easier to publish, of course. But yeah, I really hope it works, because I think I think it's been a world-leading initiative by Sadiq Khan, and I take my hat off to him for continuing to press ahead with it when there has been significant feeling against it for obvious reasons. It's not convenient at all for people in London with businesses that have to change their ways of getting around or get new vehicles and so forth. So yeah, my fingers are crossed.
I'm going to insert my own question here just before I get to Richard's next question. But I was intrigued to see that the baseline statistics from your London cohort and your Luton cohort were very similar, right? The mean values that you showed were in agreement.
Yeah.
What could you? Is there anything that we can read into that in terms of what the children have been exposed to in their lifetime up to that point?
Well, that's a good question, and yeah, of course, it may reflect prenatal factors, inherited factors, and postnatal diet, exercise, and so forth. Children in London and Luton. I worked as a GP in Hackney for 20 odd years, and a lot of the research has been on children, and there's a lot of underdeveloped children. There's a study just come out from some colleagues in QMUL on poor growth in Tower Hamlets children. So, and I think it's probably the same in Luton. So, this is a disadvantaged group, not everyone, but a significant number of them are disadvantaged. I think your comment that I'm surprised that the values are the same. Maybe that reflects the fact that we've managed to get by chance the ethnic mixes are reasonably similar. We should look at a breakdown by ethnic group and see whether there are differences. That would be an interesting thing which we haven't done.
Thanks, Chris. So Richard's question in the chat here is, related to his question earlier about diesel versus petrol exhaust, and he says, could the principal pollutants of concern to health be petrol related rather than diesel related? For example, the lead replacement anti-knock compounds that have been added to petrol, as lead has been taken out of petrol.
Yeah, I don't know the answer to that. I have not come across any discussion of anti-knock components in petrol, and maybe Richard, you've got some insight into that. It is always difficult to tease out the relative contribution of the different components of air pollution, as I'm sure everyone on this call knows. I don't know the answer to that. Have you got a comment, Richard?
The reason why I was so concerned about it was because I remember in 1976, these compounds were introduced with no real debate. And there was significant health concerns about them before they were introduced. When they were trialed in America, for instance, people used to wear gloves because they could be absorbed through the skin. And then I think because of the automotive lobby, basically wanting high compression engines and performance, that was not questioned. And within a month of the trial, they were introduced without any health studies at all. And I always remember the smell of those compounds after that, because I could smell them, and they're quite nasty smell, actually. It used to make me feel sick every time I used to smell them. But I wondered if anyone had observed a health, because you could see a step change, I think, perhaps in the health, if it was having some effect on everybody when they were introduced. It was a long time ago, I know, but yeah, it's always been my worry about those compounds. And diesel could be masking those effects, because wherever traffic is high, they will be high as well.
Yeah, I think I don't know if there are any toxicologists on the call who might comment.
It's a very interesting suggestion, Richard, and Peter's got a follow-on comment in the chat, which said, and he says it's possible that most of the health effects are not due to NO2, but to a range of pollutants which correlate with NO2. If so, might catalytic removal of NO2 only be less effective than we might expect? So addressing NO2 might not be addressing the pollutants that are correlated with NO2, I think, is Peter's.
Yes, it's going to be interesting. Hopefully we'll have some results that are analyzable if we can continue to track these children. And it may be that I know that the environmental research group at Imperial are fantastic at measuring all sorts of things that you've never heard of. And it's quite possible that they'll be able to add to the mix a range of other potential pollutants, and if we see differential changes in those over time, then it may be the statisticians can tease out potential.
May not be shown in respiratory health so much as some cancers, perhaps, because these are, I think they're called BAPs and PAHs. Yeah. They're all multi-organic ring compounds, similar to benzene and those sort of things. So they have been connected before with health effects. And what I was concerned about was they weren't considered during the introduction because it was such an emergency to get rid of lead.
Yes. Well, I'll ask my colleagues at Imperial about that because it sounds an important question.
I'm no health expert. I'm just an engineer. I'm sorry, but anyway, thanks. Right.
Downplaying yourself, Richard, to say just an engineer. So we've got a couple of minutes left. I think we've got through all of the questions in the chat. Chris, I'll just give you an opportunity to say anything else that you think is worth mentioning.
Well, I don't think there's any on the call, but I take my hat off to the team actually, because they're the ones getting up early in the morning and carting the gear around. it's it's hard work, and when you have to add another year of data collection on the end of the study, then that's everybody got to gird themselves for another year's worth of hard work. So I see there's a. Oh, well, that's very kind of Jemima to say grateful for the research. Yeah, I'll pass that on to the team.
Yeah, so for people who haven't seen that in the chat, says Ruth here, as a parent of child with respiratory issues, I'm grateful for all the research that's being done.
I think, I mean, if there's one other thing I'd say is that, on the positive side, visiting primary schools and doing stuff with primary school kids is an absolute delight. And so there are worse jobs out there. It's always fantastic to be in schools because they're always so keen and excited about everything.
Peter says, I'm looking at methods for measuring PAHs, etc. in PM, which is where most of it is.
I've got a feeling that the environmental research group have got a handle on PAH, but I'm not sure. I'll ask.
Yeah, there are some regulations, but it's not measured routinely from what I'm aware of. And Peter, if you've got any follow-on comments, and please unmute yourself or write them into the chat. Okay, so we're just coming up to the end of the session. I just want to say thank you, Chris, again for giving up your time and joining us from a conference today. It's been a really interesting talk, and I think we all wish you the best with the rest of the study, and yeah, really look forward to looking at the results. Just to mention, next week's seminar is there's two speakers, both based in Cambridge. So Anne-Marie Hindley, who's at Cambridge City Council, and Jenna Panther, who's at the University of Cambridge. They'll be talking about challenges, opportunities, and learnings from a feasibility study of school streets and no-car zones around schools in Cambridgeshire. So thanks again, Chris, and thanks to everybody for joining today.